Okay, boss. In the last class, we've been discussing what makes HANA so fast. We've been seeing something on the hardware innovations, and we've been looking at software innovations. Out of it, we've been discussing on row store and column store. So pretty much we understood that in case of row store table, each row is stored in a continuous memory locations. In case of column store, the values of a particular column are stored in one continuous memory location. Yes. And when it comes to reading data from the table, obviously when you're reading complete record, row store is faster, more kind of operational reporting. But when you're reading certain columns of a table, then column store is faster. Okay. And then when it comes to inserting, generally, if you look at normal concept of tables, row store is faster. But we've seen how SAP is handling the insert operations on the column store. Every time you create a column store table, it is actually creating two storages in the backend. One is main and delta. And delta is more optimized for writing. So every write operation takes place into delta. Then at later point of time, asynchronously, not at the time when user is entering in, asynchronously we'll run something called delta merge, which will take data from delta store to main store. And every time you read data from the column store, it does read from main as well as delta. And this merging, when you look at delta merging, it could be auto merge, forced merge, critical merge, smart merge, and we'll have different types of merge. We'll discuss on that later. But only thing is, it cannot do. Hello? Can you hear me now? Can you hear me now? Hello?
Yes, we can hear you.
Yeah. Okay. It's hardly less. Okay. Now, fine. See, if others are able to hear, then there's something problem from your side. Please just look at. Not able to view the screen. Yeah. That's my. Yeah. Okay. It was about merging. So we'll have different types of merging, something like auto merge, smart merge, forced merge, critical merge, all this. We'll see on the types later. But only thing is, just to understand there is something auto merge which is handled by the system. Within the system, you'll have a process called delta merge dog, which will be actually scanning through all the tables. Whenever any table satisfies the auto merge decision function, it triggers merging on the table. That is auto merge. If you want, you can switch on the auto merge on a table, or if you want, you can switch it off. If you switch it off, you have to take care of you should take the responsibility of triggering the merging. Okay, we'll discuss on that later. I think problem should be from your side, Tilak. Others are able to hear me, boss. You just try to log out and log in again. Okay. So that's what we've been looking at. Then we said, apart from this insert operations and write operations, in case of column store, each column values are stored in one continuous memory, and it stores only distinct values, not the duplicates. So when it is storing distinct values, it is reducing the amount of memory which is required to store this column will be less, because it is storing only distinct. Let's say you got 1 million records, and let's say I have a column called region. The maximum distinct cardinality values are only 4. Maximum distinct, let's say, then what happens in the memory? It does store only 4 values. So the amount of memory required to store 4 cell values or 4 data cells, if it is store, you end up storing the same region with 10 million cells. So there's a lot of difference in the memory being occupied in case of column store and row store. And one more thing, since it stores only unique values and will point out to every row and I told you there's something called positioning indexing which tells you which values refer to which rows. So because of this, it acts like an index. Each column which is storing as unique values itself will act as an index on it. So when you're trying to run your queries to read data from the table, pretty much fast in case of a column store. So now look at this. This is okay. This is what they're saying. So if it is row store, this is like row, right? Each row is stored in a continuous memory location. If it is column store, the entire columns values are stored in one continuous memory location. And let's see if you're saying say, select sum of certain value, you're just reading one column. If it is row store, it has to go through every row and then get you values. If it is column store, it just has to read only one column. Now look at this sizing. Why is this small and why is this big? Here the statuses are closed or open. So it stores only distinct values, so the memory allocated for that is really less. And when you try to run a query saying select sum of order value, you're just reading only one column of it. So it just scans through only a memory location where this order value is being stored. But if my query is say select star from this table, where so and so order, you're trying to read one particular row. Then which is faster in this case? If it is column store, it has to use positioning indexing. It has to go to memory location 1, get the value, go to another memory location, scan through all the memory locations and get the record. If you're trying to read select star on one record, row store is much faster. That is what we've been seeing. Yeah. So you know about main and delta, write operations is done on. Yeah, write operations should be on to the delta, and read operations is both on main and delta bus. And whenever you whenever the write operations write the data into the delta, when you do delta merge, from delta it is moving data towards main bus. Now we will discuss on how does it be. But people on the online, please mute yourself, please. So there is a document from SAP which tells you how is this indexing is done on this column store table or what it is. Yeah. Now let's look at it. Now look at this. Is this point true? In a column store table, every column is considered to be an what? Index. So question is, normally in SC11 you go about creating a secondary indexes on a table. Normally when you're trying to do a where clause on a primary key, the performance is better. Now when you do a where clause on non-key columns, obviously the performance is low. To improvise it, you build a secondary index like ODS, right? But what we're saying now, every ODS or every table, every column store table, each column itself will act as an index. Do you still need an index, second index on the table? That's the point of discussion. Okay. Now what SAP says, since each column itself will act as an index, most of the queries are really fast. Okay. But if you're trying to write some queries on a column store where you're trying to be very selective, saying you give a lot of selections in the where class. Select so and so from this table, where field 1 is this, field 2 is this, field 3 is this, field 4 is this. Lots of where class. You're trying to be very selective. In that case, having index might still improve the performance of that query. That's what SAP says. Now look at this. But that's not about, you can reduce the CPU consumption, all this, and now we'll see. Look at this. Then column store, I told each column is values are stored in one memory location, and it does use something called positioning indexing to find out which value belongs to which row. Now this is how it looks like. Look at this. For example, you have it does use dictionary based integer coding and maintains those in positioning indexing. Means like say I have a column called country for which I will have to store. How does it store that column? Look at this. So I have this value Atlanta, Berlin, New York, all this. These are my countries. For each of this country, it does associate one numeric value, which is an integer bus. So for each like SID bus, for each alphanumeric value, it does generate one integer value, which is something like SID, which is what we call as integer coding bus. Dictionary based integer coding. For each value, it does associate one integer here. And then this is what positioning indexing. In the positioning indexing, it maintains for this value of 0, which row does it maintain this? this is your row ID. Let's say, you getting what I'm saying? There might be 1 million rows. Now I need to know this Atlanta belongs to which row, right? So based on this, now Atlanta, let's say 772 New York. 772 belongs to row ID 1, and 772 again belongs to which row ID was? 254621. Getting this? This is called as positioning indexing. So it does combines the concept of dictionary-based integer coding, which will reduce the size, okay? And so instead of repeating the alphanumeric value, it does repeat the integers. Okay, and this is called as positioning indexing. Say, so for each alphanumeric value, it does generate one value ID, which will be an integer, and corresponding to this integer, it does know to which row does it belong. That is called as positioning indexing. ఓకే, ఒక్కొక్క కంట్రీకి ఒక నంబర్ ఇచ్చేసి ఈ నంబర్ సంబంధించి ఏ రోలో ఉంది డేటా అన్నది పాయింట్. అప్పుడు నువ్వు పలానా రో అన్నప్పుడు ఆ రో నంబర్కి ఏది వాల్యూ పట్టినా ఆ నంబర్ బట్టి ఆ న్యూయార్క్ అని తెలుస్తుంది అన్నట్టు. అది లింకింగ్ సంథింగ్ లైక్ ఎస్ఐడి కాన్సెప్ట్ ఉందన్న. దట్ ఈస్ కాల్డ్ as dictionary based integer coding. So now the point is, when it is getting stored in this way, this is like normal column, okay, without any additional indexes. So if this is there, if I need to read all my data, let's say I say select net sales, select country from this table. So I'm reading 2 columns, fine. But if I need to read all the countries and all the sales, do I need to scan through all these rows? I know for each row, I know which country is it. But at the end of the day, I need to scan through the entire values of this positioning indexing to know which country belongs to which row. Then I need to go to net sales corresponding to that row. I need to pick the net sales and join those. Yes or no? If I have 1 million records, will I have the positioning indexing with 1 million rows? And I need to scan through all the 1 million rows to get that value, right? That will be normal column store. If I create additional indexing, this is what happens. It creates, look at this. It creates an additional indexing here. Now how does it happen? Now look at this. Suppose it does have an integer for each of the country value, and for each of this value it maintains to which rows does it belong. It maintains all the row numbers separate with commas like this. Look at this. For this country New York 772, it represents row number 1, comma, then 254621 is row number. It maintains all the row numbers corresponding to that there. That is additional indexing what is maintained. So when I say I want to pick up all the records where my country is New York, then for New York it first gets the number as what? 772. Corresponding to 772, it need not scan through everything now. If it is a previous case, in the previous case, I need to scan through all 1 million records to find out all the rows relevant to 772. But when I have additional indexing here, I don't have to scan through everything, because if I just go to this indexing row, for 772, I know the corresponding which rows does it belong to. And straight away, I'll read only those rows. Now, in this case, I may scan through all 1 million rows to find out the rows of my country 772 New York. No, right? That is what additional indexing will help you if you want. It will have positioning indexing. Even after having positioning indexing, you still see the query is really slow. You can still build your additional indexing. If additional indexes are built, you will have an additional index like this, which says for a particular integer coding, to what row numbers does it belong to. That is how it is. ఒక్కొక్క ఇంటీజర్ కోడింగ్ కి ఆ రో నంబర్లన్నీ పక్కన కామాతో రాసుకుంటుంది. ఆ నంబర్ బట్టి రో నంబర్ బట్టి స్ట్రేట్ అవే ఇట్ విల్ రీడ్ డేటా ఫ్రమ్ దోస్ రోస్. ఇట్ విల్ నాట్ స్కాన్ త్రూ ఆల్ 1 million rows. In the previous case, it has to scan through all 1 million rows and find out the records respect to 772. In this case, just since there are additional indexing being built, okay, it knows for 772 what rows do I need to refer. Straight away it refers only those rows. That is indexing. Indexing ante ante kada. If you just have only normal positioning indexing, which is default, then once you get the number saying for New York the number is 772, I'll have to scan through this. Look, this is my value index, this one. I'll have to scan through the complete positioning indexing to find out what are the different rows for my 772. So if I have 1 million rows, will I be scanning through all 1 million values to find out what is row ID for my 772, right? But if I have an indexing here, now once I know for New York the number is 772, I go to this inverted index and find out for 772 what rows do I need to refer, and I refer only those rows. Will it not be faster? So here I'm missing out the operation of scanning all 1 million rows. That is index. Addition, if you want, that is the second indexes if you want. But generally without second indexes, they are pretty much fast. If you still, it is being more selective and you still want to improvise it, you can have second indexes. This is how it forms. Clear on this? Yeah. Now you should understand how does it read those values from the database now. Yeah. Yeah. Okay, boss. So we've been looking at the reasons of improving the performance of the applications running on HANA, right? That was one about using column store and row store. Now tell me, as an architect, if you've been given a chance to decide, let's say you're building an application database on HANA, what type of table would you choose? Column or row? Nothing. Good by default, column. Okay. And what we were looking at, that was reasoning why we would say column store table. So now column store, generally I'm building using a HANA database for our analytical processing. So I'll go with column store. And since it is able to handle write operations, I can still go with column store. And it is more compressed. The way it stores my data is more compressed with the help of dictionary based integer coding. So I'll go with what? Column. And each column itself will act as an index. So I'll go with what? Column store table. And if you just dump your data in column store, you don't have to really worry about normalization also. Previously, when you're trying to build a database, we used to be really worried about normalization. If you remember, now tell me, we know about cube in BW, you know about master database. Now, why don't I store all master data also into my cube? Say, for example, now simple, let me make it simple. We're trying to build a queue with, say, customer number, metal number, sales rep number, price, quantity, revenue. With relevant to customer number, you're trying to maintain the master data in separate table with customer address, name, region, all those stuff. Why am I doing? Why don't I bring even the attributes also into the cube? What will happen if I do that? Why don't I store master data also into the cube? Can I put the characteristic customer address, name, region, country, everything as characteristics in my cube? Yes.
Duplication.
Duplications. Exactly. So redundancy of data. So that when I start storing like that, if one customer performs 1 million transactions, I end up storing that particular customer information 1 lakh times, where I'm wasting a lot of database space. Right? That was normal database. But if it is column store table, I don't really worry about, because even if customer performs transaction 1 million times, in the back end, how many times will it store that customer information? Only once. And it points out to those rows. That's it. So I'm least bothered whether my table is normalized or not. There's no more concept of one-to-one, one-to-many. Table straight away drop into the. That's what they say. I'm having column store table, so you don't have to worry about normalization. Just dump your data at any detail level. System will handle the performance because it is going to treat each column separately. I don't have to worry about normalization, denorm, nothing. Now, actually, in the previous normal databases where we were supporting row store, when they were building BO universe also, they used to have a lot of tables because of normalization. They spread the data into a lot of tables. Then universe, they used to bring in all the tables, then do join, then they used to have looping, all the stuff. Now we are building a solution. There's no more multiple tables, like max 1 or 2 tables. Table like someone design architect, there's no use of an architect now. You can just dump all the data to one table, irrespective of whether the table is in what detail, system can handle the performance because of the nature how it actually stores the data in the column store table. That is where this concept was coming with S4 HANA. What they've seen is normal ECC, there are lots of tables, right? They are making focus was on normalization. Once they wanted to have the application make it compatible towards HANA, they're not worried about normalization. In all the tables, they just removed the unwanted columns and they made all those columns into one big table. That's what they were saying. We are reducing number of tables. They're saying in FI, they're getting into 32 tables or 12 tables altogether. That is what they're saying, simplified. I think most of denormalization. Even though it is denormalized, system will handle that performance. So majorly the point is you end up storing data in a lot of tables to normalize it. At the runtime of the query, join is a costly operation. You end up again joining those tables to get the results, which is going to affect your query performance. Now just dump data into one table and then get your performance. Am I able to eliminate those join operations during the runtime of the query? Will it improve performance of the queries also? Yeah. That's the point. That is how we should start looking at designing the database. Don't worry about normalizing or denormalizing, because for data warehousing we would prefer denormalization. It is much more better. Just dump in, then start running queries. And so then you can eliminate the joins at the runtime of the queries. That is again improves your performance. And you don't have to worry. And major worry was that the data is redundant. It is going to waste a lot of space. But even though data is redundant, it does store only what? Unique values internally. So you don't have to worry now. That's the point. And I was literally worried about this because even SAP IQ supports the same columnar storage. So now they asked me a question. What is the size of the database you are planning? We are implementing IQ bus. So they asked me what is the size because before I install the setup, I need to specify the cloud, how much of database size, how much of space do I need for my database, whether it is 2 TB or 1 TB or 3 TB. In general cases, what happens, they'll give you the size of the source database, which from where we are trying to extract. And based on that size, I can calculate how much size I would need when it comes to in HANA bus. For example, say I have a DB2 database where all metadata is stored, which is let's say 100 GB. Now I know what is my size of that footprint is what 100 GB now. To store this 100 GB of data into my database, how much size? Approximately we'll say 1/4 of it, say 25 GB plus some additional we'll just give it. But for my case, it was all PDFs, all the forms, PDF forms and XML forms. So I don't have a size like that. Then each PDF was around 6 MB. Each PDF was around 6 MB. Then what we did is we literally loaded we extracted the data from one PDF and then loaded to a column store table. It was occupying around 3 MB. Okay. Then we thought each file is going to take 3 MB. Then what we did is we just loaded 100 forms. The size was still around 4 MB only. Why? The size of the table was only 4 MB only, just increased by 1 MB when it's to loaded 100 forms. Because there's a lot of data duplicate redundant, so it does store only unique values in the backend. That is what the major benefit of column store table. Then we decided for one form we'll be just having around 10 KB. We came up to for one form 10 KB, but then we calculated based on that. Say we said we wanted to have 1.5 terabyte. Because till today is okay, but next 5 years also I need to consider sizing. Then we said we want only 1.5 TB. That's fine. And they have formed another database in DB2 where it was occupying almost 4 TB. But for my data warehousing with IQ, we just occupying only 1.5 TB.
We cannot hear you.
Now, can you hear me now?
Yeah.
Okay, fine. You're able to hear me. Yeah.
Hello.
Yeah. Please.
Sir, as of now, we are maintaining the header data, line item data, scheduled line item data in 3 different tables, right?
Yeah.
So you are telling that the entire data need to dump in only one table instead of EKKO, EKBO, EKET?
Now, what I'm saying is, even if you dump all those 3, nothing wrong. That's what I mean. I'm not forcing you to dump everything into one table. Even if you dump, nothing wrong in it. That's what I mean. Because it's not, why am I splitting into 3 tables? Because I want to normalize so it does not occupy more space. Because of the backend architecture of column storage of data tables, even if you store redundant data into it, it is not going to occupy more space.
Okay, yeah, that is
Okay, that is one.
So what would be the best practice, sir?
Best practice is you try to push in all data into one table only, because I can eliminate joins at the runtime of
Duplication.
duplicates.
Okay.
Even though there are duplicates, it's not going to increase my space. Okay, that is one point. And one more point is if I spread across into multiple tables at the runtime of reporting, I'll end up joining those tables again. Header has to be joined, item has to be scheduled. So join operation is always considered to be costly operation during query. Okay. If I can put all
query time will take time.
Exactly. So I can eliminate that kind of operation. So I can speed up my querying. Yeah.
Okay.
Yeah. Okay.
one question. Sir, I have another question.
Yeah.
So if user is doing transactions, if you have done the schedule line item, it will store data in only one table, or it will store as usual 3 tables. How it will be stored?
See, we are looking at HANA being implemented as a warehouse, right? When you see in
Yes.
ECC, let's say it is got, you'll have header, item, schedule and separately. If you want, you can bring all the data into one table. If you want, you can spread that into 3 tables also, depending on your model. Okay.
Okay.
But
Okay, sir.
I don't prefer to maintain nulls. For example, sometimes when you're bringing data of multiple structures into one table, you end up having nulls. That I would not suggest, because just for blank, I don't want to waste the space. Yeah.
Okay.
And the max size of a table would be 2 terabytes. Max size of a table can go up to 2 TB. One table size can go up to 2. So you also have to consider even the size of the tables, because if I start dumping everything into one, there will be a break point as 2 TB for one size of a one table completely. So how do we solve that problem again? Is we do partitioning. So if we do partitioning, each partition size is limited to 2 TB again. So I have a table. If you just have a normal table, max size is 2 TB. If I have a requirement to store more than that, let's say I wanted to store 8 TB of data, then what we can do? We can enable 4, like normal queue partitioning. I can also partition my table also in the database. Then each partition can go up to 2 TB. If I create 4 partitions and have the data split equally, then it can store 8 TB also. Okay, no? Okay. Right. Next reasoning about why the application. So now next is, why are the applications running on HANA are really fast? Okay. Next reasoning is push down the logic. This is what we've been discussing other day, right? In a traditional, see, any application you'll have front end and you'll have back end, right? So let's say in the traditional applications, what happens? You've been using the database just for storing data, and actual processing of data is all done by your what? Application server. Let's say you want to process some data. What do? You read all the required data from database to the application, then process the data, then send the data back to what? Database or to the front end. So then what SAP says, 60% of the application time is spent in reading in and out of the database. So they want to eliminate that, those particular timing of the application. So then what they have done is they've come out with a new model where the logic is written in database server itself. Application server will be just used for control flow logic, just for controlling that logic. That's it. So whenever I have to perform some data intensive logic, the logic is written with the language which is understandable by the database and have been pushed down into the DB server. So when I have to execute certain logic, then my application server just takes the command and triggers the code which is written in database server only. So when I'm executing logic within the database server, the data is not moving out of the database. Data is within the database server, and logic is also getting executed inside the database server. So I'm eliminating the time taken of the data movement from out of database server and coming in and out of the database. So am I improving that 60% of the total time? That's the. This is like pushing down the data intensive logic deep into HANA database. That should be your focus. So there was some, our students who have been saying, or my friends, even after migrating their BW system to HANA, they could not see much of the performance improvement. It's not about just having HANA, it's about using HANA. You have to pressurize HANA, because HANA is able to process data in peak time. You have to put a lot of pressure onto it. Only then you go to get the results out. Even after having HANA, if it's still executing your logic with ABAP server, then what does it make sense? You have ABAP application server, you have database server in the backend, and database server also can execute your operations, and ABAP server also can execute your operations. But the performance, when it executes with the database, is much faster, I'm saying. Now, even after having HANA, you're still executing your logic with ABAP layer, ABAP server, then what is the, will you get any difference? No. So it's not about just having HANA, it's about pushing down the database intensive logic deep into HANA database. That is important. Clear on this bus? So that is, so if I need to push down my logic into deep into HANA database, I cannot write ABAP program this, because ABAP is not understood by my database. I need to start implementing my logic with some programming language which my database can understand. That is where the concept of scripting comes in. So if you need to write some data intensive logic which is understandable in my database, so for HANA we will write SQL script. If it is database, we used to write for Oracle PLS.
So do you mean to say in the database server level, writing of ABAP code doesn't give any sense to improve the performance?
Exactly, because if you write an ABAP program which is executed with ABAP application server, what you will do? You will write a select, collect the data from the table into internal table, process all the data in the application server, then get the data back to the database or back to the front end bus. Okay, but if I'm doing with database, what happens? So I'll write all my logic with SQL script, which is in what? In the database layer only. So I'll just have a cover. I'll be having the covering of that scripting with an ABAP layer. All the text box or front end will be with ABAP. So once I say execute this, your ABAP will just call the stored procedure, which is implemented with SQL scripting, which is in the HANA database, and the SQL script will perform the logic for you. That is the two different ways. So I'm saying the second one will give you high performance. That's where the concept of ABAP managed database procedure comes in. You'll have an ABAP class with a method where the method is declared as HANA database procedure, where the method will have, instead of ABAP, they'll have SQL scripting in it. So at the runtime, the logic is executed deep in HANA database. With that, you start pushing down data intensive logic deep into HANA database and get high performance. అది HANA కొనుక్కుంటే కాదు, దాన్ని వాడాలి, దాన్ని ఫుల్గా వాడాలి. ఎంత వాడితే అంత పర్ఫార్మెన్స్ అన్నది. Exactly. Yeah, because you write your stored procedure. Like in ABAP, you have got functions, function model, action, perform statement, all this, right? Same subroutines, all the same way. You'll have some different kind of artifacts you can write. So you can write a stored procedure, you can write a function, and call them whenever you want. Also, yeah. SQL script.
Sir, I have a doubt here.
One second. In HANA for scripting, you use SQL script. Like similar to in Oracle Cloud, they use PLS code. Here we use SQL script. And even what they've done is, apart from using SQL script, make your logic simpler. First, mute yourself. I'll give you a chance to answer. Please mute yourself. To make it simpler, what they've also brought in something called, instead of writing everything with SQL, they also give some CE functions. I told you, calculation engine functions for ready-made. For most frequently used SQL statements, they've given some CE functions, which can also be leveraged for writing your performing data intensive logic. And also when you want to perform some complex logics about predictive analytics or business functions, they've given some ready-made libraries, ready-made functions are being given. You just have to pass in the input parameters to it and then get the results out and then process it. There are ready-made libraries which are built with C, C++ and given to you for most of the predictive analytics, logics and all those. You can just use those. Instead of rewriting your logic, you can use a ready-made library delivered by SAP HANA. Yeah, now you got this point. So you can use all those and implement any data intensive logic deep into HANA database. And you'll have the application server, whether it is ABAP or .NET or Java, C, anything, will be just calling them. So the application server will become light now. They're only to control the logic, nothing else. They don't execute the logic. Logic will be in database. That's what, if it is HANA, that's what we're trying to focus. What was your question?
Sir, even if the logic is pushed into the DB server and executed at that, but still, like if I want to pull the data from 10 tables to process something, but still logically it will be the same thing, right? Even if it is executed at application server or database.
Good question. What you're saying is whether I execute the logic in with ABAP or with the SQL. Ultimately, I need to go through the entire logic. Yes, correct. Now, what I'm saying is, if I'm implementing the logic with ABAP, let's say it is running for 1 hour bus. So out of 1 hour, okay, 40 minutes of the time is spent in reading data from database to internal table, and from internal table, process data from internal table back to database. And 20 minutes was the time to process the database. Okay. Now, if I use a new concept where the logic is implemented with scripting, and I use it for executing my data logic, now how much time this should take? 20 or 25 minutes, because I am eliminating the process of data movement from database in and out. The actual time taken by the logic will be still same, 20 minutes. Either might be bit faster, but I am eliminating the majority of the time of moving in data in and out of the database. You got your answer now?
Yeah, but still not satisfied with the answer.
తెలుగు వస్తుందన్నా
No.
నా వస్తే
Okay.
చూడు
Correct, sir.
నువ్వు
The
రాసిన
data movement will be very limited, right?
కాదన్న అబాప్తో రాసిన డేటాబేస్ సర్వర్లో లాజిక్ రాసిన టైం ఓటే పడుతుంది ఈ లాజిక్ కి. కానీ నువ్వు అబాప్తో రాసినా ఉంటే డేటాబేస్ సర్వర్లో నుంచి అప్లికేషన్ సర్వర్లోకి డేటా తీసుకురావడం మళ్ళీ అక్కడ నుంచి బ్యాక్ డేటాబేస్ తీసుకెళ్ళాలంటే టైం ఎక్కువ పడుతుంది. కాబట్టి ఇప్పుడు డేటాబేస్ సర్వర్ లాజిక్ రాసినాం అనుకో, కోడ్ అక్కడే ఉంటుంది, డేటా అక్కడే ఉంటుంది. కాబట్టి జస్ట్ అక్కడున్న డేటాను వాడుకుని లాజిక్ ఎగ్జిక్యూట్ చేయడం. డేటా బయటికి రాదు, లోపలికి పోదు అన్నట్టు. బయటకు వచ్చేది లోపలికి పోయే టైమింగ్ అంతా తగ్గుతుంది. వాడు ఏమంటే ఆ బయటకు వచ్చి లోపలికి పోయే టైం ఎక్కువ పడుతుంది అంటాడు అప్లికేషన్ మేజర్ గా.
ఓకే ఓకే, అంటే ఇప్పుడు లాజిక్ ప్రకారం కొన్ని టెంపరరీ ఇంటర్నల్ టేబుల్స్ డిక్లేర్ చేయాలి అంటే, బట్ డేటాబేస్ సర్వర్ లెవెల్లో ఆ టెంపరరీ ఇంటర్నల్ టేబుల్స్ డిక్లరేషన్
ఎట్లాగంటే అట్లా. ఈవెన్ వైల్ రైటింగ్ SQL scripting, you will still have the concept of temporary tables, like you can bring out a concept like internal table, looping, giving, ఇష్టాసరం చేయొచ్చు.
యా యా యా, అవన్నీ ఉండాల్సిందే సార్. అవన్నీ లేకుంటే అంటే మనం లాజిక్ ప్రాసెస్ చేయలేము. ఓకే.
ఇంకా ఇలా టెంపరీలో కూడా చాలా టైప్స్ ఉంటాయి అన్నట్టు. గ్లోబల్ టెంపరీ టేబుల్, లోకల్ టెంపరీ టేబుల్, అండ్ ఈవెన్ యూ డోంట్ హ్యావ్ టు డిక్లేర్ దోస్ టేబుల్స్ ఎక్స్ప్లిసిట్లీ, దే గెట్ డిక్లేర్డ్ ఆటోమేటిక్లీ. ఇలా లాట్స్ ఆఫ్ ఆప్షన్స్. విల్ సీ దట్ while writing scripting.
Okay. Okay.
Yeah, whatever I said, Telugu was nothing new. It was all the same what I discussed in English, so not to worry who don't know Telugu. Yeah. Next question.
Yes, sir. మీరు చెప్పింది ఇప్పుడు ఇది న్యూ డెవలప్మెంట్ కి, ఇప్పుడు ఆల్రెడీ ఎగ్జిస్టింగ్ BW ఎండ్ రొటీన్, స్టార్ట్ రొటీన్ అవన్నీ ఉంటాయి. డూ యూ నీడ్ టు కన్వర్ట్ ఆర్ రీరైట్ ద కోడ్ విత్ రెస్పెక్ట్ టు DB సర్వర్?
గుడ్ క్వశ్చన్. నా ఎగ్జాంపుల్ ఏంటంటే, వాట్ దిస్ క్వశ్చన్ ఇస్, for all the new developments what I do, obviously I will write transformation with expert script routine because I know now. But what happens to the previous transformations what has already been written? That's what this question is. Whether will I convert that or will I not convert it? Okay. Now tell me the question, will I convert it or will I not convert it? It's not, no one is forcing me to convert. Now what I'll do is, if that is my main pain area, I'll convert it. So let's say I love my BW. Once I migrate it on HANA, because it's not, I know technology, but I should also consider the costing from the customer side also. After migrating my build system onto HANA, if I need to do optimizations again, that will be a big project again. Every customer is spending money in buying HANA and then migrating it, but still they're not releasing budgets for optimizations to be carried out after the migrations. But let's say they're not spending any money, but let's say they have major problem area. There is one particular load which is taking almost 4 hours every day. And they observe that most of the time is spent at the transformation level because it's been a lot of heavy ABAP code which is written and it's taking a lot of time. In that case, I would obviously spend some money on it and improve because after driving HANA, if I'm not still improvising that, so in that case, I'll start rewriting that logic with what? SQL scripting. But there is another data flow which is just running in 10 minutes. I'm okay with that. I'm happy with that. So in that case, will I rewrite my logic again in that case? Majorly, I will catch hold of the problem areas and then start tuning it. Until నాకు డబ్బులు ఎక్కువ ఖర్చు అవుతాయి కాబట్టి నిజంగా ప్రాబ్లం ఫస్ట్ ఐ ఫోకస్ ఆన్ సాల్వింగ్ ద మేజర్ ప్రాబ్లమ్ ఏరియాస్. Then when I have lots of money, then I'll spend money on other topics also. Because I had a lot of because there will be definitely a use case why they're buying HANA. They'll just not buy HANA first. In the existing BW system, they would list out all the pain areas for which they're trying to buy it. Because everyone should have a business case why they're buying HANA. They're just not buying HANA like that, right? So let's say they'll say in the existing BW system, I have problem of data loading. Most of the data loads, they're taking 4 hours, 5 hours because of heavy customization in the transfer. Let's say that is the business case of my user who is buying HANA plus. After buying HANA and after migrating his BW system onto HANA, you still have those problems. Then you have to address those. If I'm not addressing those problems, then there's no point in buying HANA. In that case, I'll have to rewrite my transformations with the ABAP managed database procedure by implementing HANA expert script routine and improvise those loading performances. Yes, because if you're having normal standard transformation like direct mapping, constant routine formula, all those, but that is by default pushed into HANA. But when the moment you start writing ABAP in the transformation, the logic is not pushed into HANA, that is executed in the application server. In that case, If you impress, you have to write, you have to convert those transformations with what? SAP HANA expert script routine and push the logic into HANA database.
How it's going to be basically like the app is completely rolled
We'll see. Which one?
That's what I'm asking. Like, as you're telling that if you write the code in a app, basically, it will go to the app server. So the coding which you have to do for HANA,
actually, you'll still use ABAP for wrapper. Actual data intensive logic will be scripting, and that cannot be exposed to the front end to the customer, right? So you'll have ABAP wrapping against wrap the procedure and we'll be exposing it. So ABAP will be used as a wrapper, and the deep logic inside that will be with scripting. That is called ABAP managed database procedure.
okay. So basically, the kind of thing will be like we'll be creating the function and all through SQL.
Yeah.
We'll be calling those procedures to ABAP.
Exactly. Even if you look at Fiori and all those, what you'll write scripting, you'll have the logic with the scripting, and with ABAP you'll create a OData service, and that OData service will be binded to the UI elements what you design with Fiori bus. So actual logic you have to push in with the deep HANA database by using scripting, and that will be going to connect to whether you expose that with the ABAP managed database procedure or through OData service and you link it to Fiori, whatever it is you can do. Okay, so this is one reason of improving performance. Next.
Hello.
Yeah.
సార్ ఒక డౌట్ ఇప్పుడు ఈసీసీలో కానీ సిఆర్ఎంలో కానీ హనా డేటాబేస్ యూజ్ చేస్తే
నేను తెలుగు
పాత లాజిక్ సారీ
if you ask the question in English, the others also can understand. Yeah, that is better.
Okay, so like if we use the HANA database in place of Oracle or some other databases like NCRM or ECC, what will happen to the old logics? How we will just handle that situation?
See,
like if we use
exactly, he's saying if I migrate my ECC application from non-HANA database to HANA database, the ABAP programs what are there still available will still work as it is. It will not be any difference, but there will be still a scope to improve performance on that further, because let's say you written a lot of ABAP programs. If it is non-HANA databases, when you're writing select statement with for all entries is a better option, but with HANA for all entries is not a good option.
Okay.
For other databases, writing select star is a good option, but with HANA select star is not a good option. So what happens? What SAP has done is they have given a certain note called ZBW underscore ABAP underscore analyzer. This will basically analyze the entire ABAP code and will tell you this statement can be improvised. It will scan through, if it is BW, it will scan through every ABAP code you written in process change, transformation, everywhere you written, it will scan through everything. It will tell you at this line you have written this select statement, this can be improvised. I can show.
Okay, that means all the select queries like Oracle select queries will can be used here, right?
Yeah, you can use, but we don't know about the performance difference. Okay.
Okay, that's all my question. Thank you.
Yes. See, this was an ABAP analyzer report which we run for a different, because before customer prefers HANA, we are running this program and then find out what all programs have got the problems, which has to be tuned. Okay, this comes as an he's just giving some warnings here, saying you have used select. There are some end routine in some of the transformation where they have used select star here, and it says for all entries, and it's giving me saying a warning here. It is not red. Red means it cannot run that step. It is able to run that, but that can be more optimized. That's what this program gives me. This will scan through every transformation, everything, every code you might have written in APD, or it could be transformations, or it could be inside the process chain or new process type, info package, data selection coding, DTP selection coding, everything it will scan and then tell me wherever there is a problem, which can be improved. See, again, wherever it is select something you're using for all entries, major problem would be with star and using for all entries. Now, this is what you can do. So I think that is what he was asking me. The existing ABAP program will still work, but if you want it to be tuned more towards the HANA database, we'll run this program ZBW ABAP analyzer, which will analyze all the ABAP programs and tell you which part of the ABAP program has got the problem. There are notes which tells you how the ABAP coding should be written if it is the HANA database in the back. There's some changes.
Okay, okay. We need to follow that note. Okay.
Yeah, exactly. Yeah. And even for this implementing SAP BW ABAP analyzer, this is a note again. There is a note which we have implemented. This actually, when you go to that note, it actually gives me a program which I have to create it. And then when you run the program, you get this output. This is actually a separate note. దీనికి నోట్ కూడా కావాలంటే this is a note number 1847431 is a note.
Okay.
And when you get to this note, so when you get to this OSS note, you can just you can just go through this note, okay, and you'll have a zip file below. Look at this, and you have a PDF also. The PDF is just to understand what does this program do. This will tell you about the program, what does it'll just explain you about what does it'll explain every transformation, update rules, transfer rules, everything can be debugged. Okay. And then if you get to the zip, this would give me, if I download the zip, this will give me the program. Now if I go to this if it is BW 3.5, use this program. If it is 7, use this program. If I open this won't give me a lot ready-made ABAP program. So I just have to copy this and create an executable program, and then when I run the program, I can have those screenshots and get that output, which can be exported as an HTML file. And that's where, because as an architect, before we go with migration, I'll have to estimate how much of work would I have. So before I go with, I'll implement this node in the system and see how much of problem we have with ABAP, how much of customizations, impact analysis will I have to do with respect to ABAP. Then based on that, we go with estimating the time, how much time does it take to move this. Okay. So you got your answer, Bush? That was
It answers for the queries you said, it will be like there will be other note to check. I'll check on that one if I found anything.
Exactly. There'll be not Google on like more ABAP customizations specific to HANA ante adi daniki malli separate untundi.
Okay.
Okay. Next is about partitioning. Next is about partitioning. Okay. So you know about partitioning, just splitting the table into multiple parts, but you'll have different types of partitioning also. Let's not worry now, but let's discuss on there's something like hash partitioning. When I say you'll have hash partitioning, range partitioning, round robin you'll have, and multi-level partitioning you'll have. We'll discuss on that later. But now, when you say hash partitioning, let's say you have a table, okay, and I would like, if I store all this table into one particular node, imagine I've implemented my HANA server with multi-node architecture. When I say multi-node, 4 CPUs together are acting as one HANA server. Okay. In that case, if I store all my table data in one node, and whenever I process my data, the pressure is always on that node. Okay. Now what I do, if I distribute this particular table content into 4 different nodes, and when I execute my query, the pressure is, so all the nodes have to run their respective data, give it, and then consolidate this. Now the pressure is spread across the nodes first. Do we have load distribution there in that case? In the cloud, you'll have another component called load balancer, which takes care about this load balancing. But by using partitioning, we can spread the table content into multiple nodes or multiple RAM or multiple nodes. Each node will have different main memory. I can spread the data across the multiple main memories. So when I run my query, it has to read data from node 1, node 2, node 3, node 4. Then the pressure of running this query is distributed across nodes. Okay. That is what partitioning. Next, we'll have something called compression. We have seen this dictionary based see. When you have column store, it actually stores only unique values, and for each unique alphanumeric value, it does generate one integer and then stores the repeated values with numbers, not with alphanumeric. So will that reduce the size required to store the data bus? So what they say is, since we use this dictionary based integer coding, when you get the external data, like say now presently I have data in my DB2 or say Oracle. When I get the data into HANA database, it will be compressed to 1/4 of it. Say if I have 100 GB, by the time I store it, minimum I would achieve it as 25 GB. But there are always there are some cases where they could compress it to 89% of it or 80%, 70%. There are some cases where they could only compress only 1% of it, because if the source data is already compressed, then when you bring that into HANA database, you may not fetch so much, because if my source database is SAP IQ, which is already column store, which is pretty much compressed, if I bring that data, you may not be getting much difference in the sizing, because that is already compressed one. Okay. So majorly, this is a basic algorithm, but there were lots and lots of algorithms in the backend for having this data compressions done. If you can understand this dictionary-based integer coding, that's fine. For each of the alphanumeric value, it maintains one integer, a numeric value, which by using those numerics, it maintains those values. That is called dictionary-based integer coding, more like an SID concept. Okay. Okay. And then we said no more aggregate tables. You understand now? Because of the column store architecture, column store table architecture, we can dump data in any detail. So no concept of aggregations. So with respect to BW, most of the architects, what they do now is before HANA in LSA, they'll have staging layer, they'll have transformation layer, they'll have some reporting layer. On top of it, they try to build some summarized aggregates or the summarized cubes. They try to maintain DSO as a very detailed one, and they try to maintain cube as more aggregated one, and they do reporting on the cube. Now, what is the purpose of the cube? When I'm loading from the DSO to the cube, I'm not doing any transformations, but only I'm using this cube just to store only with required info objects, so that data is more compressed, right? Now, what they say is with LSA++, with HANA coming as backend with BW, if I'm using cube on top of DSO just to aggregate my data, those cubes can be eliminated out and have my reports straight away done on DSO. Why? Because all this becomes column store table. Even though data is detailed on the column store table of my DSO, it can still handle the performance. So once we have it HANA, the performance on my cube or the DSO is one and the same now. So if I'm just using cube just for aggregating it, I can eliminate those cubes and start using the DSO for report. But if I'm using this cube for snapshot scenario or something, then the cube is important. I'll hold it like that. Okay. So now if you look at the new set of providers, what they're trying to do is they're trying to eliminate all the cubes, okay, and then replace the cubes with advanced DSO or with standard DSO. Because advanced DSO maximum number of key fields is only 120. Now can I say in a cube, every characteristic is a primary key? So if I have a cube with within 120 number of characteristics, I can replace that with an advanced DSO where all those will be acting as a key. If the number of characteristics in a cube is more than 120, I cannot accommodate that with an advanced DSO. Then I'll have to go with what? Standard DSO and handle that within that 16 limit. I'll handle it, and then do reporting either on standard DSO or advanced DSO, or combine them in composite provider and then do reporting. There's no more cube concept. And the cube, if I'm just using cube only for aggregating, we can eliminate it. But let's say we're using cube for snapshotting or something, then you can still hold it out. Now they were saying, or in case of inventory, for non-cumulative cube, you still might need the cube. But now,
exactly.
But now there is a new note out where you can also implement non-cumulative concept with advanced DSO also. with non-cumulative cube might be still necessary, but there is already a note out which says even with advanced DSO you can implement that inventory cube also. So if that is the case, then cube to man pane ledannattu. Okay.
So how this HANA will work on non-cumulative?
One second, there's a question. If there's two things here, upgrade, migrating and optimize, the three things. You have to upgrade, migrate, optimizations. Upgrade is you're upgrading because only from BW 7.3 version it supports to have HANA. So let's say the customer is running your BW system on 7.x or 7.1 or whatever. Then you have to upgrade the BW system to 7.3 minimum, but SAP has to go with the latest release. Okay. Then you have to migrate the database from non-HANA database to HANA database. Then you have the system. Then once you have the BW on HANA system, then you have to carry out the optimizations. Now what I'm seeing in the market is majority of the customers, they are migrating it to HANA, but still they're not releasing budgets for optimizations. I don't see much customers doing optimizations after only major pain areas they're touching, but big customers like they are doing a lot of optimizations or replacing queues with advanced DSO. They are doing, but mid-level customers, they're still not releasing budgets for optimizations. So all these three different things.
Include a condition that maximum dimensions are 16 and key figures are a number. So will that condition satisfy DSO also if you go on
DSO concept very good. Now maximum number of key fields 16.
Same.
And even with HANA optimized cube, maximum number of dimensions are still 6. Actually dimensions, but literally there will be no dimension, but we'll discuss on that. 16 dimensions to 240 per dimension, those still restrictions still holds good even with HANA. Okay. So now let's get into architecture first. Now let's get into HANA architecture first. So when you say HANA architecture, we're just trying to understand what components will it have, or what engines will it have, and what does each engine do. Okay. So we know HANA is a database. It has to store data, and it has to process those queries, because when I try to read the data, it has to process those queries. So what are the different components that are available in HANA which will enable you to store the data, and what are the different engines or components available which will help you to process your queries. Okay. So when you install HANA, it could be single host or it could be what? Cluster also. If you have cluster, then load balancer comes in. If it is single node, no load balancer, nothing. So it depends on the sizing of HANA server, what do you want. If the sizing is vast, they'll go with what? Multi-node cluster, or if it is single node. Okay. Major in HANA database, the major server would be index server. Server ante system kadana, software. Server ante computer kadu. Any computer can be called as a server if it is running server software. So when I say index server, it is not a system, it is a program. It is a program. So any system where my index server relevant program is running, I would call that as index server. When I say server, it's actually a system where my server software is running. That is what my server system, right? So index server is actually set up. It's again a program. Now when I say index server, this is the main server which actually handles your database. So index server.
Sorry to interrupt.
Yeah.
Yeah, can you tell me why we use multi-node cluster?
Why we use multi-node clusters? Because now we have a limitation saying we can only have a motherboard with max up to 12 cores, or 8 CPU processors, and each processor can have up to 12 cores. If your requirement is you want to go beyond that,
okay.
If your requirement is to go beyond that, obviously you have to split that into multiple motherboards. Then each motherboard will be a separate node. Then. Yeah.
So as of now, any of the clients doing that?
Most of the clients do go with multi-node only. Only small customers would go with the single node.
Yeah. Okay. So PepsiCo and
only multi-node, because when I'll show you the server, when I get into the server, I'll show you. If it is multi-node, you'll have multiple index servers. Ante. If it is single node, you'll have only one index server. Ante. That is only.
Okay.
Like all the nodes will be a dialog instances, and you'll have one central instance. You'll have one server which is playing a central instance, and we control all other nodes. That is called multi-node. Yeah.
Okay.
Okay. So out of this HANA database software, you majorly have a program which is called as index server, which mainly handles your database processing of entire HANA database, like creating of table, inserting data in table, reading data from table. All entire database is handled by that index servers. All your database operations about creating tables, creating database objects, inserting data, deleting, all this handled by your index. That is a major server for you, okay, for processing your databases. Then we'll have another server called preprocessor, another set of programs delivered as a set as preprocessor server, which is used for processing of unstructured data. So even in HANA, we have a concept of processing of unstructured. Let's say you give me a lot of data in a very big PDF file. We can take that unstructured data, give out sentiment analysis on top of it. Let's say I get a lot of reviews on Cubex Institute. I can take all those reviews and also give out sentiment analysis on top of it also. So those kind of processing of unstructured data is also possible with HANA because of this preprocessor servers. Okay. Then we have something name server. This maintains information about landscapes. Now, what does this name server do? Now, we just said we can have multi-node architecture, right? Then I said let's say I've got 5 nodes. Out of 5 nodes, one should be a central instance, and other would be dialog instances. So the integration saying, okay, this is central instance. All these nodes are connected to this node. Now connection or setup is all done by name servers. Okay. Then we'll have statistics server. All the programs relevant to statistics server will be used for collecting statistics of every operation you do. So say, for example, you insert some data into a table. It collects the statistics saying how much time was taken to insert it. It collects every statistics information about for every operation is carried out. That is taken care by your statistics server. Okay. Let's not worry. We'll come to this point. SAP car and see, this will host agent will be majorly for transport. See, do you transport objects from one development system to quality production? That can be handled by host agents. Yeah, and then there will be something SAP car and the normal exe file. What normally does is some of the software what is given by SAP would be .car files and all. If it is zip, or you say you extract that with the zip software, right? But if it is car files, you have to extract them with SAP car as a software. As a exe file, then what to extract this. Solution manager common is like normal solution manager for any Solomon. Okay. Then we'll have HANA Studio. This will be the front-end client tool. Like for SAP systems, you install SAP GUI, right? Same way when you want to work on HANA server, HANA server is different. You'll be sitting on a client system. So in the client system, you have to install HANA Studio. And once the HANA Studio is installed, using HANA Studio, you'll start working on to HANA server. So HANA Studio, HANA vere kadanna. HANA is a software. So it will have client software, it will have server software. HANA server software is the database. HANA client software is your HANA Studios, which you have to install in the client systems to get connected to your HANA servers and start working on it. That's like a GUI, okay. And you'll have repository, all the server space, server folder structure is what we refer to as server folder path, and we call that as repository. And then it will have normally any software would have connections through which we upgrade that software. Then we'll have upgrade manager, which will upgrade the existing HANA versions or HANA software. Now when we open this index server, this is how it looks like. Because index server is the one which actually handles the complete database, right? Now when you open the index server, these are the components you will have, and each component will be for different purpose here. Now look at this. You'll mainly have something like connection and session management, and then you'll have request processing, and this all the components within index server, okay? And you'll have a block for processing your request, and any incoming request to the database, those requests are processed with this block. And you'll have row store engines and column store engines. And you'll have, I'll come to this, persistency layer of, see, I told you about data volume and log volume. This is not part of RAM. This is part of the disk, okay? And this is part of the RAM itself. This is part of the server itself, persistence layer. I'll come to that. and then we'll have metadata manager, authentication, session, and then what is this? Transaction manager. We'll have all these components within it, and we'll have to see what does this each of the component does. Okay. Now look at this. Let's say you have a database, and we have got some tables, and they obviously try to read data from the tables, right? Let's say you've been doing reporting with some BO or some Excel or whatever it is. Now what do you do first before, if I need to read data from HANA or something, first I need to get connected to the HANA database, right? Even if I create a universe in BO on top of HANA, first I need to create a relational connection which will connect to the database, right? Same way, now look at this. So you'll have some username and password, login with the login credentials. You get connected to the HANA database. Once the and when you pass in the username and password, it has to be authenticated, right? Whether this is correct or not. So that is all taken care by what is your authentication count. This will check the authentication, and if it is all fine, it allows it to log in. Once the login is done, that will be a session. Normally, even in SAP, when you log in, when you say you open multiple screens, each screen is like one session. So once you get connected, you establish a session with the HANA database, and the sessions are handled by session component. So all the connection and session management is all handled by your authentication and what sessions. It checks the authentication, and once it passes through the authentication, the session is established. So there is a permanent connection between the external system towards HANA. So the connection would be set as what session. Okay. Now once we have established session, now we start running a query from external environment. You say select column 1, column 2, column 3 from a table. That is what the query you're running, and that is like a request towards my database. And the request comes in, it gets into what SQL preprocessor. This will parse the SQL statement. This checks whether the syntax of the SQL statement is all fine. If it is able to perform some smaller operations, it will be carried out in SQL processor. And then it sends on to respect engines to perform that operation. The SQL query comes into the SQL processor, it checks the syntax. If it fails, then you get an error saying the syntax is not fine. If it goes through the parsing of the SQL statement, then it sends it to SQL script. SQL script is what to execute your SQL statements. And if you want to execute the CE functions, I told you calculation engine functions, complex calculations all handled by your what calculation engine. And then if your incoming query is not SQL query, if it is an MDX query, then that will be processed by what MDX engine. And if it is for planning applications, that will be taken care of by planning engine. So you'll have respective engines which actually does it. Actually, there will be two more engines. One is called as overlap engine, and one is called as join engine. Major engines would be calculation engine, join engine, and overlap engine. As part of HANA modeling, we'll see there will be three types of view. We'll pay particularly attribute view, analytical view, calculation view, right? So when you execute a query against an attribute view, it will use join engine. When you execute a query against an analytical view, it does use overlap engine. When you execute a query against calculation view, generally it uses calculation engine. But within the calculation engine, you have a property called execute in SQL engine. By default, when you execute a query against calculation view, it has to use calculation engine. But we have a property called execute in SQL engine. Then in that case, it executes that query on a calculation view using SQL script engine. I can also switch like that also.
When will the planning engine be used?
When you execute your planning applications with IP or BPC on the top. When you have BW sitting on top of this, running your IP or BPS or BPC, then the planning so then the logic of planning applications are executed deep into HANA database with this planning engine. Okay. Let's say any of these engines, most of the engines, what they do join all those, right? But actually, I will join the data after I read data from table. I need to read data from the table, right? So all the table manipulations are handled by a row store engine and column store engine. If it is a row store table, handling of row store table, organizing those tables, storing, everything is handled by what? Row store. Same if it is column store table, it is all handled by your column store engine. Why the importance of this engine is very, very important, because see, we have row store, we have column store, right? Actually, internally, to store the column store table, it does use different set of data types. Normally, we'll have different data like small int, big int, integer, float, real, varchar, all those, right? internally for column store it does use different set of data types. Okay, but SAP never wanted me to know the data types of row store and data types of column store. Never wanted me to know. So it will be one set of data types available. When I say create table, I see normal data types. When I choose that, internally, this column store engine will convert those data types to data types specific to what? Column store, and then create a table in the backend. For example, if I say I see database integer, internally for column store it does use a data type called CS_intent. If I say real or decimal, it will say CS_fixed. It will have different data types for column store. But when I'm creating a table with the UI or whatever, I don't have to remember those names. I'll just use normal data types. This column store engine will convert those normal data types to column store specific data types and handles the table in the backend. Okay, so there is a table I'll show you where you can know for normal data what is relevant column store data. We can see that also. These two are called relational engines. Relational means table engines. That's okay. So columns, row store and column store are referred as relational engines. Okay. Then we have something called page management, and what is this here? Logger. Now very important. You remember yesterday when I was discussing about data persistency, I told every time you write data into main memory, it will be capturing those logs into what? Log volume, right? How does it handle the collect those logs? Okay? By using these two. One is page management and what is this? Logger. Actually, in RAM, memory is always by page, 8-bit page or 16-bit page and page wise ఉంటుంది. Okay. So you insert some row or record into some table. It goes and sits into one memory location or one memory address. That memory address will point to one page bus. It will have lot. RAM is split by pages, and in each page you'll have address, memory address on it. So when you insert new record, it goes and sits into one memory address, and memory address will belong to one page bus. Page management will identify which page has been modified, which was a page in which the new data has come in. Then once the page management identifies it, and it sends the change to what? Logger, and logger will put the log into what? Log volumes. Okay. And if I lose power again, then but it reloads the data from data volume to the main memory and then re-execute these logs as we discussed yesterday. And what is the purpose of data volume? That is the actual disk where the data is stored, hard disk. Okay, so regularly we'll have something called save point. At every save point, all the data from the main memory will be written to what? To the disk. Okay. And then yesterday you asked me, suppose if I lose power during the middle of the transaction, who will handle? You'll have something called transaction manager, which actually takes care about atomicity, whether the transaction is fully done or transaction is completely undone. Okay. And then you'll have a component called metadata manager, which actually maintains the metadata database. For example, you create a table. Information about the table is stored into some standard tables. You create some view. Again, details of those views stored into some standard table, procedure, anything. So that is all taken care of by your metadata manager. Like this, you will have lots of components within your indexer which does all this purpose. This is only to understand how is it doing it internally. Okay, boss? Yeah. And same we can also look at this way also. Everything is pretty much same. Yeah. Okay. Next, we're getting into SAP HANA components. And with this, what I'm trying to understand is, with this, we can understand what are the different functionalities we can implement with using HANA. And then capabilities ఏంది HANAతో మనం ఏమేమి చేయగలుగుతాం, ఏమేమి flexibilities ఉన్నాయి లోపల. If we can understand this, then for a given business requirement, I'll be able to identify, okay, for this kind of requirement, I can use HANA. When I understand the different components, this will give you the different flexibilities or functionalities what HANA can be used. So when you understand the client requirements, you'll be in a position to identify, okay, for this kind of business requirement, I have the flexibility of implementing it in HANA. That's what we're trying to focus here. Now look at this. Within HANA, you have some replication services. With the help of these replication services, you can integrate this HANA database with SLT or site-based replication, which can be enabled to bring in, replicate data in real time into HANA. since HANA has got the flexibility of getting integrated with the real-time replication services with SLT or Sybase replication. SLT is a different server, Sybase replication is a different server. By using those, you can extract data from SAP or non-SAP in data in real time and push data into HANA. So real-time data can be extracted from SAP or non-SAP through SLT or Sybase replication into HANA through real-time replication services in what we have in HANA. So, so whenever you find any business requirement where they say I would like to do real-time reporting, can that be achieved with HANA here? Not purely with HANA. HANA integrating with the help of SLT and Sybase replication, I can do that. That's what it should have. Okay? Now we understood that in HANA it supports real-time replication services by integrating it with what? SLT or Sybase replication. So whenever I get to see some requirement from the business which says I would like to do real-time reporting, I can suggest HANA in that case because it supports real-time. That is what the point of focus is. Will come. SLT is again SAP landscape transformation. It's a dedicated middleware layer server, which will be more of an trigger based, and we can basically extract all the data from SAP source or non-SAP source in real time and push into HANA. And now with the latest support pack of SLT, we can push real time data using SLT even to BW also, not only to HANA. Till the previous support pack, SLT was enabled only to bring in real-time data from SAP or non-SAP only target as HANA. But now with the latest support DIMS 2005, we can basically push it into BW also. We'll see practically now. And then it is an in-memory database. So HANA has got the flexibility or feature of having storing data in main memory and processing data in main memory and data services now. HANA has got the flexibility of getting integrated with the BODS data service. It could be data integrator, data quality, entire data services can get integrated. So by using BODS as ETL tool, I can extract data from SAP, non-SAP, any system and push data into HANA database. So it has got the flexibility of getting integrated with BODS also. So if you look at any kind of business requirement where they wanted to build a warehouse where they want to push data through BODS, I can also still leverage HANA in that case. Now, as we said, planning and calculation engine, SAP HANA has got its own planning and planning. With the help of planning engine, we're able to push down the planning functions can be executed deep into HANA database, like your copy, repost, distribution, Fox. All this will be converted into standard store procedures, and it executes the planning functions deep into HANA database. And calculation engine is a very strong engine, and which can handle huge data and can be leveraged for faster processing. And then HANA also does give you this. I told you there's some ready-made libraries given as predictive analytics library and business function library. Ready-made functions implemented with C++ as the language they've given it. So when you want to implement some complex logic, you don't have to rewrite the logic. You just have to use the library, just call it with the required input, and then collect the data. You can also leverage some standard core logics given for implementing predictive analytics and business functions. And then it has got R integration. I told you R is a language, R river language, which is more suitable for statistical data processing. HANA also supports R integration. So within HANA, I can write programs using R language also. Instead of writing with SQL scripting, if I feel that there is some logic which is more suitable to be written with R language, I can leverage R language to implement that logic in HANA database. That is called R integration. Okay. Then next, there's something called Hadoop integration. So Hadoop, which is a distributed file system, another system. Even Hadoop system can be integrated to HANA through smart data access. There is an option called smart data access through which I can integrate Hadoop system towards HANA database. Actually, future my expectation, future they'll try to have, I was telling you, they'll have one HANA database where all the SAP systems sit on top of it. You'll have all the SAP applications sharing a single database. So this database will have all the SAP data, right? Then for all non-SAP systems, they'll try to push data into Hadoop, and Hadoop will integrate to HANA. What plan allowed, all SAP data will get into HANA database first. all non-SAP data they'll push into Hadoop systems, and Hadoop will integrate to HANA, and then HANA will start exposing data for reporting. Adi next level of now. Suppose if you have a customer who's got around some 300, 400 applications with SAP or non-SAP, all SAP systems will sit on one single HANA platform. The data base is shared across. So this will have all the SAP data, no more ETL. All this will have all the data in it. Then for all the non-SAP systems, I'll use some BODs or something and push data into Hadoop systems. And Hadoop will get integrated towards HANA through smart data access or whatever it is. Then, so HANA will have the entire data. Then we start doing reporting on top. That is what future they look at things. Okay. And then you have flexibilities of text search. When I say text search, I'm just telling you about processing of unstructured data. So SAP HANA does deliver you a lot of ready-made configurations with ready-made dictionaries available for processing, doing sentiment analysis and all those stuff. So we have flexibility of processing unstructured data and then do sentiment analysis also. So if there is a business requirement where they have a lot of unstructured data and they want to do some analysis on unstructured data, I can still leverage SAP HANA for it. Okay. And then applications I was telling you in HANA, apart from index server, you'll also have something called access engine. We did not see, but you'll also have access engine server also, extended application services where you can deploy your own applications and deploy on it. I told you native applications and non-native. So HANA has got the flexibility, provides you application services where with the HANA having its access engine where you can deploy your own applications on top of access engine, and it does provide you application because it's going to be a platform where you can deploy applications on top of it. And then modeling studio is nothing but your HANA studio. When you basically get your HANA database, you get even the client software, which will be referred as HANA Studio. HANA Studio will be a client-based software through which you get connected to HANA server and start performing all your operations what you want. Okay, that is more for a modeler kind of, more for a developer or modeler or administrator. But for end users, they give another component called information composer. Let's say what you've done is you had about calculation view, had a modeling. Let's say you created some view, okay, and you've given that to the user, and they're trying to do reporting. Now let's say apart from the fields what are there in the view, they wanted to have one more extra view. Let's say the view has got say product number, product name. What they want is apart from the product name, they want to see one more column called product class. Because based on product, they may have categorized the product class as A, B, C. They want to see product class column also. So they say I have an Excel data which tells you which product belongs to which class. Then you have to integrate this Excel data also into the view. Then I say okay. Then I say it takes me 2 months because I need to do change in development, do testing, do transport, then integration testing, go live. And just say 2 months because he wants that to be analyzed immediately. I can't wait for 2 months. What end user can do is he can use this tool called Information Composer. He can upload that Excel data by himself, okay, and then he can basically join this existing view with that Excel data and then create one more column by himself and use it for reporting. It's more like a BW workspace in terms of BW, something like that, Information Composer. So HANA, and then on top of HANA, you can do reporting with either of this Excel or business objects or any reporting component which has got SQL interface or MDX interface can access HANA database. Any reporting tool which can connect to the databases through MDX interface or SQL interface can connect to HANA and then extract data from HANA and then do reporting. So these are the flexibilities what we have with the HANA, and it can also develop some applications which can integrate with mobile applications also, any reporting components. So HANA can give you all these flexibilities. So whenever you look at any kind of business which can match any of this, then you say HANA can be used in this case. Getting this? Okay. So
Hello.
One second. So we'll stop it here for today and then we'll continue tomorrow. Any question there? Yeah.
Yeah, one question, sir.
Yeah.
Is there any case which is not handled by HANA as of now? I mean, as per client requirement, it is not suitable for HANA like that. Any cases?
Yes. Still, there is some problem with exception aggregations.
Okay.
For example, I want to get the last value, nth value or I want to get only the latest value with respect to date, then I'll do a lot of coding. There's no easier mechanism of handling aggregation, because if you look at normal measures or key figures, you will see aggregation function as count, min, max, sum. But if I want to go with different aggregation like last value, nth value, or latest value, first value, you have to write your own Windows functions and get that. There's no way solution towards that. We have that problem. Yeah.
Okay.
And one more thing.
So in that case, we need.
Yeah.
Okay.
And one more thing is, if you want to get real-time data, use SLT. But SLT can't really process your data source. It can only process your tables. So imagine if you want to rebuild the logic of the standard extract, it is not going to be very easy. That's again a limitation with this HANA. And again, some more issues is majority of most of them are complaining me saying the RAM is getting filled completely because they're not maintaining that unload priorities properly. So that's again a problem. Something which can't be handled because he's given something called a native framework. With that, it's like a programming language. I can write anything I want generally, but it is tough to implement those non-cumulative key figure concept in HANA because of the aggregation functions available as only sum, min, count, and max. Yeah? That is what the problem I've seen, but otherwise, pretty much. And if you just have HANA, you can't do planning applications, all this. You need to have BW with HANA to have those planning applications, all those running on HANA BW. You cannot eliminate BW if you want to have IP or BPC, all those. Yeah? Again. So I cannot have planning applications purely running only with HANA without BW. That can't be again. Yeah.
Sir, and one more question. You are telling that already column index is representing as index. So if you want more performance, then we need to create second index, right?
Exactly. Each column of a column store table itself will act as an index, and the performance is a lot better. But only thing is, if you're still writing some queries where you're really trying to be very selective, particular row levels, then it's better to have an additional indexes which will improve your performance.
So is there any scan, this select statement is taking more time, so SAP suggested to create an index for this one like that?
Exactly, because when you get at HANA Studio, you will see for each of the session, for each of the query, what is the total runtime. We can see the performance like that and see where it is taking a lot. We can break the big SQL into multiple parts, each operation, and what is the time taken by each of the operations, then decide whether it needs indexes or not. Yeah.
Okay. Thanks, sir.
Fine. Okay.
Sir, have you? How do we get the daily recording video? Like so far, I've not received anything.
You'll not get daily. You'll be getting it on Sunday.
Oh, I see.
Starting from Monday to Saturday, you'll get it on Sunday.
So no way to get it daily in case we miss one class. We have to wait for the full week.
Yeah, that's what the problem. Because
okay.
It takes a lot of time. Huge file, right? They will just collect all together and then they send. Because if they have to send every day, it will be tough.
Okay, sir. Also, sir, have you shared any documents so far? Because up to now, I didn't receive anything.
No.
I think the demo class.
You have to see for all the documents, videos. You have to contact Pawan. This number 9885384656 or Vinod.
Okay.
Or you can.
And then.
1 second.
So have you shared anything so far? So I think in the demo class you said you're going to share some documents.
Not you can just talk to them. Well, they'll tell you 1 second.
Okay, sir. Thank you.
Vinod number would be 9052 999949, or you can also call this number 888-623-0001, or mail ID would be, if you want, 2606-2004. You can also reply to this mail. They'll respond.
So you're sending that to all of us now? I don't see that. You sent a message with that.
Yeah, I pinged in
email
the
ID?
chat. I'm just pinging. I'm typing in the
chat. Okay. Sorry. Thank you, sir. Thank you.
Hello, sir.
Hello. Yeah.
Are you covering only BW on HANA or native HANA?
Entire native HANA, enterprise HANA, BW HANA, ECC HANA, everything is covered.
Okay. Thank you.
Okay. Yeah. Fine. Thank you.